2 juice boxes. Same brand. Pack of 6 for $4.50. Pack of 10 for $7.20. Which one is the better deal? Most people guess. Some people look at the total price and pick the cheaper one. But neither of those methods gives you the right answer. Unit rates do. And by the end of this lesson, you'll solve problems like this in seconds, not just in math class, but every time you go shopping. Welcome back to the Ratios, Rates, and Proportions series. Today, we will talk about unit rates and how they connect to ratios. Before we talk about unit rates, let's understand what a rate actually is. Because this is where many students get confused. A ratio compares two quantities of the same type. For example, 3 red marbles to 5 blue marbles. Both are marbles. Or 4 small plates to 8 big plates. While a rate compares two quantities of different types. For example, 120 kilometers in 2 hours. Kilometers and hours are different things. Or $4.50 for 6 juice boxes. Dollars and juice boxes are different things. Whenever you see two different units being compared, that is a rate, not a ratio. This distinction matters. Ratios compare same type quantities. Rates compare different type quantities. Remember this for your exams. A unit rate is a rate where the second quantity is exactly 1. The word unit means 1. So, a unit rate tells you how much of something per 1 unit of something else. Examples of unit rates you already know. 60 kilometers per hour. That's distance per 1 hour. $2.50 per kilogram. That's cost per 1 kilogram. 30 students per class. That's students per 1 class. The word per is always your signal that a unit rate is involved. Whenever you see per, you're dealing with a unit rate. Finding a unit rate is always the same 2 steps. Step 1. Write the rate as a fraction. First quantity on top, second quantity on bottom. Step 2. Divide both numbers so the bottom becomes 1. That's it. Every unit rate problem follow these 2 steps. Let's try it with a simple example. A car travels 240 kilometers in 4 hours. Step 1. Write as a fraction 240 kilometers over 4 hours. Step 2. Divide both by 4, 60 kilometers over 1 hour. Unit rate, 60 kilometers per hour. Now, let's go back to our opening question. Pack of 6 juice boxes for $4.50. Pack of 10 juice boxes for $7.20. Which is the better deal? To compare them fairly, find the cost per 1 juice box for each pack. Pack of 6, $4.50, divided by 6 equals 75 cents per juice box. Pack of 10, $7.20, divided by 10 equals 72 cents per juice box. 72 cents is less than 75 cents. The pack of 10 is the better deal by 3 cents per box. This is exactly how supermarkets calculate unit pricing, and now you can do it too. Let's try a speed problem. A cyclist covers 85 kilometers in 5 hours. Find the unit rate, kilometers per hour. Step 1. Write as fraction 85 over 5. Step 2. Divide 85 divided by 5 equals 17. Unit rate, 17 kilometers per hour. Now, a follow-up question. At this same speed, how far does the cyclist travel in 8 hours? Unit rate is 17 kilometers per hour. Multiply by 817 times 8 equals 136 kilometers. This is the real power of unit rates. Once you have the rate per 1, scaling to any quantity is instant multiplication. Let's try an earnings problem, very common in grade 7 and 8 exams. Sarah earns $114 for working 6 hours. Question 1. What is her hourly rate? $114 divided by 6 equals $19 per hour. Question 2. How much does she earn in 9 hours? $19 multiplied by 9 equals $171. Question 3. How many hours does she need to work to earn $266? $266 divided by $19 equals 14 hours. Notice the pattern. Unit rate solves all 3 questions, forward and backward. Let's now make the distinction between rates and ratios completely clear, because exam questions will test this. A ratio has no units, or both quantities share the same unit. Example: the ratio of boys to girls is 3 to 5. No units, just numbers. A rate always has two different units. Example: 60 kilometers per hour. Kilometers and hours. A unit rate is a special rate, where the second quantity is always 1. Example: 60 kilometers per 1 hour. Here is the quick test. Ask yourself, are the two quantities the same type of thing? If yes, it's a ratio. If no, it's a rate. If the second quantity is 1, it's a unit rate. Let's practice identifying rates and ratios. A class has 12 boys and 18 girls. Same type, both are students. This is a ratio. A tap fills 45 liters in 3 minutes. Different types, liters and minutes. This is a rate. Unit rate, 45 divided by 3, equals 15 liters per minute. A printer prints 120 pages in 4 minutes. Different types, pages and minutes. This is a rate. Unit rate, 120 divided by 4, equals 30 pages per minute. A recipe uses 3 cups of sugar for every 4 cups of flour. Same type, both are ingredients, measured in cups. This is a ratio. Here is the most common unit rate mistake at grade 7 and 8 level. A student is asked, which is faster? Car A, which travels 210 kilometers in 3 hours. Or car B, which travels 260 kilometers in 4 hours. The student looks at the distances only, 260 is bigger than 210, and says, car B is faster. That is wrong. You must find the unit rate for each. Car A, 210 divided by 3, equals 70 kilometers per hour. Car B, 260 divided by 4, equals 65 kilometers per hour. Car A is actually faster, even though it covered less total distance. Never compare rates by looking at one number only. Always find the unit rate first. Pause the video and solve these practice questions. Question 1. A pack of 8 pens costs $3.60. A pack of 12 pens costs $5.16. Which is the better deal? Question 2. A factory produces 360 items in 8 hours. What is the production rate per hour? How many items in 11 hours? Question 3. Identify each as a ratio or a rate. Part A. 5 teachers for every 30 students. Part B. A car uses 8 liters of fuel per 100 kilometers. Pause now. Here are your answers. Answer 1. Pack of 8, $3.60 divided by 8, equals 45 cents per pen. Pack of 12, $5.16 divided by 12, equals 43 cents per pen. Pack of 12 is the better deal. Answer 2. 360 divided by 8, equals 45 items per hour. In 11 hours, 45 times 11, equals 495 items. Answer 3. Part A. 5 teachers to 30 students, same type of thing, this is a ratio. Part B. Liters and kilometers, different types, this is a rate. Specifically a unit rate, since it's per 100 kilometers. Here is your final challenge, a multi-step problem. 3 phone plans. Plan A. $45 for 5 gigabytes. Plan B. $72 for 8 gigabytes. Plan C. $99 for 12 gigabytes. Which plan gives the most data per dollar? Pause and find the unit rate for each plan, gigabytes per dollar. Let's find gigabytes per dollar for each plan. Plan A. 5 divided by 45 equals 0.111 gigabytes per dollar. Plan B. 8 divided by 72 equals 0.111 gigabytes per dollar. Plan C. 12 divided by 99 equals 0.121 gigabytes per dollar. Plan C gives the most data per dollar, but only slightly more than plans A and B. Notice, plans A and B are actually identical in value. Same unit rate, different total cost. This is a real-world decision you will face. Unit rates make the choice clear in seconds. So, today you learned the difference between a ratio and a rate, same type versus different types. What a unit rate is, a rate per 1 unit. How to find a unit rate in 2 steps: write as a fraction, divide to make the bottom equal 1. How to use unit rates to compare prices, speeds, and earnings. And how unit rates solve problems, forward and backward. In the next lesson, ratios versus fractions. How they connect, how they differ, and why confusing them costs marks on exams. Subscribe and don't miss it. And don't forget to follow us on Facebook, Instagram, and TikTok. Thanks for watching. See you in the next lesson.